Assalamu alaikum guys. So in today's lecture we are going to do the new topic of our topic of our physics syllabus, which is motion, okay? Or we may also know now nowadays it's known as motion, and before its name was kinematics, but they both are the same. So let's start with the definition of motion. What is the definition of motion? Basically, when when a body does not change, when a body continuously changes, okay? Continuously changes When a body continuously changes its position with respect to its with respect to its surrounding, okay? Its position with respect to its surroundings. To its surroundings. So this is known as motion. This is the definition of motion. Okay. So you guys have to note these points because these are some very important points. Okay. Now, what is the opposite thing of motion? Basically, the opposite of motion is rest. Or let's first write the some examples of motion. So what can be the example? It can be, for example, the Earth. Okay, the Earth. How is it? The Earth rotating around the sun. Okay, so in this, for example, let's suppose this is sun, right? Okay, and here, wait, okay, okay, and let's suppose this is Earth, right? So after some time, when the time goes on, Earth changes its position. Okay, and for example, comes here and then goes here and then over here. So hence it changes its position, right? So this hence it will come in motion, okay? And there's another example can be that when like for example um electron orbiting the nucleus, okay? It is also an example of motion, okay? Electron orbiting to the nucleus, okay? Nucleus. Okay, so this is the second example. Now let's do rest, which is the opposite thing of motion, okay? Wait, let me write this rest. Okay. So basically, what is rest? Rest is actually when its definition is when a body does not change its position with respect to its surroundings. Okay. So this is the definition of rest. So what are some examples of rest? So one example can be like a book. Okay, a book lying on a table because I just saw a book and now that it was lying on the table. Okay, and another thing can be a calendar hanging on a wall. Okay. Okay. So calendar hanging on a wall. So we are done with the rest. Okay. We are done with motion also. Now let's show that what is distance. Okay. So let's write distance. So what is the definition of distance? Distance is basically the path or track between 2 points. Okay. A path or track between 2 points. Okay. So for example, like here's this dot and here's another. So this path, or let's suppose this path, or for this path, or if it's this, so this is called as distance. Okay, so it doesn't need to be the straight line. Okay, or the shortest, because it can be the shortest, it can come from everywhere. Okay, so this is distance. Okay, distance. So basically distance is a path or track between the 2 points. Now what is the symbol of distance? Okay, so the symbol of distance. So what is the symbol of distance? It is basically d, small d, okay, and it is a scalar quantity, okay, and with it, it's SI unit. So what is the SI unit of distance? Basically, the SI unit of distance is meter, okay, meter, okay. So this is a symbol, and this is the SI unit. Now let's do some conversions, okay, conversions. So in this, basically, let's remember some things. Like for example, 1 meter will be 100 centimeter, okay. 1 meter is equal to 1000 mm, okay, because these conversions are really important, okay, and do come in our paper, okay. Like 1 centimeter is equal to uh 10 millimeter, and 1 kilometer is equal to 1000 meter, okay. So we have to remember these, okay. So now let's move on to displacement. So basically, displacement and distance have a uh, difference, okay. So and because distance is a scalar quantity because it has only magnitude, okay, while the displacement, wait, the displacement is the what? Displacement is the vector quantity, okay, vector quantity, okay, because it is the distance covered in a direction, the shortest distance, okay, shortest distance covered in a direction. So the shortest distance means the distance in a straight line or somewhat like this. It is called as uh, displacement, okay, or the shortest distance is called as displacement, okay. So now let's write the definition of displacement. So what is the definition of displacement? It's the wait, yes, the shortest or minimum distance between 2 points, okay, is called as displacement. Displacement. So the straight line distance between 2 points, this can also be the other definition of displacement, okay. It is in a direction, okay. So its symbol is also d, but with a arrowhead because it is a vector quantity, okay. Hence it has a arrowhead, and it is so we are done with this. Now let's do what is a physical quantity, okay. Physical quantity. So a physical quantity is anything, okay, anything that can be measured, okay. So anything that can be measured is called as quantity or physical quantity, okay. So it's called as physical quantity. Like there are some examples of physical quantity. It can be luminous intensity, okay, means intensity of light, okay, we can calculate it, okay, and temperature, mass, and many other, okay. So I have made a lecture on this, and you may see it, or and you may see that lecture because it will be uploaded. It has been uploaded. So now let's do what is scalar. So basically, scalar is it is basically it has value, okay, value slash magnitude, okay. Basically it only has a value or magnitude, okay. So so basically they are those values, okay, or those substances which are completely specified by their magnitudes are called as scalar quantity, okay. Okay, any substance which are completely specified by only their magnitude to you. So they are called as scalar quantity. Okay, quantity. So we're done with scalar. Now let's do the last topic of this lecture, or okay, which is vector. Okay, so what is a vector or a vector quantity? Vector quantity or vector is those quantities. Okay, those substances. Okay, which are completely, completely specified, which are completely specified by their magnitude, sure, and direction. Okay, and direction. Right. Yes. So which we not try. Okay, I think I guess basically we right. Yes, so we okay. So this is the definition of a vector quantity, and it some example can be like acceleration is also a vector quantity. Okay, because weight is in a direction. Okay, it's basically a speed in direction. Okay, velocity, weight is also a vector quantity because it's usually downwards. Okay, so this is the I haven't written some examples here, and this is some examples can come like speed. Okay, speed because speed can be in any direction, density, and so on. So that's it for today, guys. I hope you like the lecture, and we will soon be uploading part two of this lecture. Okay, so you I hope you guys have understood the main points in this lecture: the definition of vector, scalar, what is displacement, what is distance, what is rest, and what is motion. Okay, so that's it for today, guys. So I hope okay, guys. So we'll see you in the next class. Allah Hafiz.